Optimization. To optimize means to either find the maximum or the minimum value of a quadratic relation. So the point that you're looking for is the vertex of a parabola. Now, let's just recall the ways to go back to vertex form to find the vertex. Here's our vertex form. And when we are in standard form, to get back to vertex form, we've got two choices. So we could either use complete the square method, or we could use the midpoint. Right, this is the axis of symmetry equation, minus b over 2a. If you are in factored form, we need to use the midpoint to get back to our vertex form. So we're going to be using our midpoint equation where we take the first x-intercept, add the second x-intercept, divided by 2. This is going to give you the axis of symmetry. You have your h substituted into an original equation to get the corresponding value of k. Let's do some questions now. So the sum of two numbers is 16. Find the numbers if the sum of their squares is a minimum. So let me just explain this question for you right now. What they've told us is we've got two numbers. So I'm going to say let A be the first number and let B be the second number. What I do know is that the sum of these is equal to 16. And the other thing I know is that a squared plus b squared will be some sort of minimum. So when I say minimum, let me explain it like this. So here's our aside. We know that there's lots of combinations that can add to 16. For example, if I had 1 plus 15, this will equal 16. My A is a 1, B is 15. I could have 2 plus 14 is equal to 16. 3 plus 13 is equal to 16. And so on. You see the pattern here. Now, if I had these two values and I were to take the square of them, it needs to create a minimum value. So I have 1 squared plus 15 squared. Let's throw that into our calculator. 1 squared plus 15 squared, 226. Okay, for our next one, we have 2 and 14. So 2 squared plus 14 squared is 200. Third one, 3 squared plus 13 squared. 3 squared plus 13 squared, 178. Now you see the numbers are going down, meaning there has to be some sort of minimum. Because at one point in time, when you get to the end, you will eventually have 15 plus 1 is equal to 16. And our values would be just like what we had before. So it kind of goes up. These ones go down, but the sums of the squares, they're decreasing, and at some point in time, it increases again. So what's the minimum value that could be produced with these two combinations of numbers. So when we solve, let's rearrange our equation so that we could stick our first equation into the second equation. So here's my equation 1a. I'm going to rearrange it. B is now equal to 16 minus a. Sub 1a into equation 2. A squared plus 16 minus a all squared is equal to some sort of minimum. I'm going to rearrange this equation. I'm going to say m is equal to a squared plus 16 squared, 256, minus 32a plus a squared. I'm going to continue to simplify this equation until I get a quadratic relation that I can work with. Okay, so this is our quadratic relation in standard form. For me to get the vertex, I need to convert it into vertex form by completing the square. So let's take this point, and I'm going to start completing the square. Now, first step for completing the square, we're going to take the 2, factor it out of my a and b term, a squared minus 16a plus 256. Now I need to introduce my c term. M is equal to 2a squared minus 16a. My c term is the b term divided by 2 squared. So 16 divided by 2 is 8. 8 squared, 64. I've introduced 64, but I'm also taking away 64. Right, we've rewritten the question now. Let's continue to find our perfect binomial, a minus 8 squared. Now that is these first three terms factored to our perfect binomial. Now inside our binomial, or inside our big bracket, we still have the 64, and we're adding 256. I'm going to expand now, take the 2, multiply it with this term here, and the minus 64. So m is equal to 2 times a minus 8 squared minus 128 plus 256. Collect our like terms. M is equal to 2 times a minus 8 squared plus 128. Now we can find the vertex. Vertex is the h and the k. In this case, the coordinates that I'm using for the vertex, I have a and m. A being the first number and the m representing the minimum. So my first number is 8, and the minimum that we're going to get is 128. So at one point in time, we have 128. So we have our first number, but the question's asking for two numbers. So I'm going to come back to my first equation. A plus b is equal to 16. For me now, I need to find my b term. B term, substituting it back in, would be 8 plus b is equal to 16. So if a is equal to 8, then 8 plus b is equal to 16. So b is also equal to 8. Our solution here, the two numbers that we have is 8 plus 8. They sum to 16, and the sum of their squares is the minimum value compared to everything else we have.